PCS 100 UPS-I is a high-efficiency single-conversion industrial UPS. In this animation, you can see the current flowing from the utility to the customer's load. There is also a voltage sag approaching the customer's facility. When the UPS-I detects the sag, the inverters start. Customer's load is supported via the inverter's start, taking direct current from the capacitors and inverting it to the perfect sine wave to supply the customer load via the coupling transformer. When the sag is over and the UPS-I judges that the utility is stable, it will synchronize with the utility and transfer the customer load back to the utility. After the transfer, the inverters now recharge the capacitors. It's made up of 4 principal components. The utility disconnect is a low-loss, ultra-robust SCR thyristor switch. The component supports the load current and can commutate off in less than 2 milliseconds. The inverters is a redundant modular system that supplies power to the load during power quality events and also recharges the PCS 100's UPS-I's batteries or capacitors. The capacitors are an example of storage used. They provide 15 years lifespan and are proving very reliable in the field. The coupling transformer connects the inverters to the customer's load and provides a neutral as well as adapting the inverters to the customer's system voltage. The fail-safe bypass, FSB, is an optional item that allows full automation of a wraparound breaker as well as providing backup protection to the load. For this demonstration, the PCS 100 is connected to a sag generator. For this purpose, we should initially be starting the UPS-I to put it in the ready state. This is the normal mode of operation, and the UPS-I is only expected to put in standby mode before being powered down for maintenance purposes. The UPS-I is now ready, and the sag generator will now create a 50% remaining voltage sag. We will review the event and the UPS-I response from the UPS-I GDM. You have seen the change of state as the UPS-I supports the load. The storage voltage level in the bottom right-hand corner shows the voltage level of the storage as the capacitors discharge. Now that the sag has been completed, you can see the UPS-I has returned to the ready state and the DC voltage of the storage returns to 750 VDC as the capacitors have been recharged by the inverters. The utility voltage sag we have generated is typical of real-world events that stop productivity and cost industry millions of dollars. By overlaying the UPS-I output during the event, we can see that the UPS-I has detected the event and transferred the load to its inverters and storage, thus providing continuous voltage and current to the load. Final analysis, the customer's load is protected by the PCS 100 UPS-I. UPS-I benefits: 1/4 the size of traditional UPS solutions, industrial rated, class-leading efficiency of typically greater than 99%, redundant fail-safe design, which means that if a fault should occur, the inverter will be seamlessly removed from service, preventing a process shutdown. Typical payback periods for our customers have been between 9 to 18 months. ABB, world leaders in power protection products, provide leading-edge technology, service and support, producing power and productivity for a better world.